Yeah, okay, Mr. Johnson. I know you found another rock. I'm not interested. Look, I've got to go. Look, okay, I'll talk to you later. Oh, hey, guys, sorry, I didn't see you there. I was just on the phone to Mr. Johnson. He's found another rock, but I want to go through a couple of examples on how to solve simultaneous equations using substitution. First of all, we'll talk a little bit about, what it actually means graphically. We know that linear equations are used to represent straight lines. So I'll go through the key ideas here, and hopefully that'll make a little bit more sense about, what's actually happening here. So essentially, with simultaneous equations, we've got two equations which is represented graphically by two straight lines, and we're actually finding the point of intersection. So our answer is going to be a set of coordinates, an x value and a y value. Lines that aren't parallel will obviously have one point of intersection. Lines that are parallel, so they have the same gradient, we know that they'll never meet, therefore there'll be 0 points of intersection, and they can't be solved using simultaneous equations. So today the video I'm going to show you involves the substitution method, and this is used when at least one of the equations has one variable for the subject, as the subject rather. For example, y equals 3x plus 2 or x equals 3y, take 1. You can see in the second equation x is the subject, in the first equation y is the subject. I'm going to go through a couple of examples here, but essentially it's about substituting one equation into the other and solving for either x or y first, and then using that coordinate or that value to solve for the other pronumeral. So let's look at these two examples we've got here. We've got two equations. Let's go ahead and write them down. Y equals minus 3x plus 2. Let's label that as equation 1. And we've got the second equation, y equals 7x minus 8, and let's label that equation 2. Now what I'm going to do is, and just referring back to this second dot point here, where we're using substitution because the variable is the subject in at least one of those equations. In this case, it's actually the subject in both those equations. Anyway, what I'm going to do is I'm going to substitute equation 1 into equation 2. So I'm going to rewrite these two equations as 1. So how's that going to look? Instead of y, we know that y is also minus 3x plus 2, so I'm going to write minus 3x plus 2, and that's equal to 7x take 8. Okay, I've substituted equation 1 into equation 2 because we know that y is equal to both of those. So that both right-hand sides of those equations are equal to each other. Then we're going to go ahead and actually solve for x in both those equations. Let's start by removing x from one side. I typically like to target the negative value, so I'm going to get rid of the minus 3x by adding 3x on the left-hand side. That means I need to add 3x on the right-hand side. I'm then left with 2 equals 10x minus 8. Okay, to isolate x, next step is to remove the 8, so add 8 to both sides. Okay, and then left with 10 equals 10x. To remove the 10, the operation between the 10 and the x here is multiplication, so the opposite of that is to divide. So I divide by 10 on both sides. And zoom out a little bit. 10 divided by 10 is 1. And we're left with x. So x equals 1. Then what I'm going to do is I'm just going to use the value of 1 for x and substitute it into either one of those original equations. Let's just go ahead and substitute it back into equation 2 because It's got a positive coefficient for the value of x. Just makes that a bit easier to work with, in my opinion. So let's rewrite that as y equals 7 times by the value of x here, which is 1. Take 8. So y equals 7 times 1 is 7. Take 8. Y equals -1. So the point of intersection between these two equations is a set of coordinates 1 and -1. Okay, guys? So that's how you solve simultaneous equations through substitution. I'm going to do another example. You'll see in the second example here, if I just make a bit of space so you can actually see those equations. In the second example, you can see that only one of those equations has the variable as the subject, which is equation 2. I'm going to start by the same process. I'm actually going to write those two equations, label them 1 and 2, and substitute one into the other. So let's give ourselves some room here. In fact, I'm going to delete this first example. There we go. So, start again with equation 1, 2x take 3y equals -8. That's equation 1. And y equals x plus 3 is equation 2. Again, I'm going to substitute equation 1 into equation 2. So I'm going to rewrite it as one equation, which will look like this. Instead of y here, I've got 2x take 3 times, in fact, y is represented by x plus 3. X plus 3 equals -8. Alright, this is slightly different. Now x is on both sides. Both x's are on the same side of my equation. So I'm going to go ahead and expand my brackets here. So I've still got 2x. Now I'm going to use the distributive law to expand the bracket here. So remember the distributive times in the term in front of the bracket by each term inside the bracket. So I'm going to start with minus 3 times by x, which is minus 3x. And then it's minus 3 times by positive 3, which is minus 9. And that's equal to -8. Then I'm collecting my like terms. You can see I've got two like terms here. 2x and minus 3x is equal to minus 1x or minus x. Take 9 equals -8. From there, I can just solve for x. So for me, I like to remove the 9 first. So add 9, do that on both sides. Minus 1x. Oops. Stick to black. Minus 1x equals -8. Oops. Add the 9, equal to 1. And then to remove the minus 1 there, I'm going to divide by minus 1 on both sides, giving me an answer of x equals -1. Now with that value for x equals -1, I'm going to substitute that back into one of the original equations. Again, the second equation looks a little bit more simpler here, so let's go ahead and use that. Y equals, instead of x, -1 plus 3. So y is equal to -1 plus 3, which is 2. And the answer is then, as a set of coordinates, x value first, -1, y value second, positive 2. And there you have it. That's how you solve simultaneous equations using substitution. Hopefully this video helps. Use it as a bit of a blueprint for the questions today I've put up on DayMat. And yeah, if you've got any questions, send me a DayMat message. Thanks for watching.